All right, class, welcome back. This is 8.6. It's just going to be more graphing of quadratic functions. So over here to the right, I have written all the things that you need to know how to do. And I've written the two forms that we have talked about and worked with so far in the class. So the standard form of a quadratic function, ax squared plus bx plus c, and the vertex form. So and when it's in this form, the vertex is whatever h is and whatever k is. And the previous video talked about how we can take the opposite of b and divide it by 2 times a, get the x value of the vertex, and so on. So we have talked about how to find the vertex in the other videos. But again, if it's in this form, the vertex is going to be h and k. And if it is in the standard form, then I'm going to use the vertex formula to find the vertex. So we've talked a lot about how to find the vertex. I'm not going to go into depth in that in this video, but we are going to talk about how to find the y-intercept and how to find the x-intercepts if they exist. So it's important to note that every single one of these parabolas, because they open, like this, no matter what, if they go on forever, regardless of where they open, if they open upward, downward, left, right, if they're shifted left, shifted right, shifted up, shifted down, it doesn't matter. That at some point that parabola will cross the y-axis, and that will be the y-intercept. Well, how do we find a y-intercept of anything? Well, if we're looking at a graph, remember that the y-intercept is just like where that crosses. And anytime we're on our y-axis, x is 0. Okay, anytime we're on the y-axis, x is 0 because we haven't moved at all to the right or left. So the way we're going to find it, I'm going to work in these 4 functions here, and we're going to find the y-intercepts. The way we're going to do that is by plugging in 0 for x. And then we're going to say, okay, well, what is y? So when x is 0, what is the y value? All right, so when the value of x is 0, what do I get? Well, all of this is 0, so I literally get then that y is equal to 3. So y is equal to 3 when x is equal to 0. So in this case, my y-intercept is equal to the point 0, 3. Okay, that's y-intercept. Well, how is this one different? It's not. Y-intercept just means plug in 0 for x, because when x is 0, you will be on your y-axis. Again, 0 times anything is just going to make these go away, and that means that in this case y is negative 10. But y is only negative 10 when x is 0. When x is 0, we get a y value of negative 10. That's true if it looks exactly like this standard form, and it's true if it looks like some alteration of this standard form. Okay, so again, I can just plug in the f of 0 here and say, well, that's 0, so y is 1. Well, y is 1 when x is 0. And when x is 0, we are on our y-axis. So this would be my y-intercept for this one. Again, there's only going to be one of them, because this parabola is going to open upward, downward, or whatever the case is, but it's only going to cross the y-axis one time. Okay, so there is only one of these. Only one. Okay, this is really important to understand. Okay, and when x is 0, what is y? Again, so when x is 0, if I substitute 0 for x, that's what it says, the f of 0, then what is y? Well, here, anything times 0, that's going to cancel out, and so is this. So this just says that y is 0. Great. So y is 0 when x is 0. So this y-intercept then is 0, 0. Hopefully seeing this process through like 4 different times with the same concept, it will really help you understand the concept here. Again, this was finding, or how to find, the y-intercept. Now we want to figure out how to find the x-intercepts. Well, just like finding the y-intercept is plugging in 0 for x, to find the x-intercept, again, if I I look at this and this parabola goes like this, right here and right here are my x-intercepts. Well, I have 2 if it crosses the x-axis. And I'm going to find those when y is 0. So this is when y is 0. We want to find out what x is. But this one is a little more tricky because it can either cross twice, or it could look something like this, where this is a min right here, so it's never going to cross the y-axis. Or it could look something like this. Sorry, it's never going to cross the x-axis. Or it could look like this, where again, it's never going to cross that x-axis. So these will literally have no y-intercepts, or x-intercepts, oh my gosh. These will have no x-intercepts right here, these 2. Okay, this one has 2. So let's talk about this. We could get a 0 x-intercept or 2 from what we've talked about so far here. So let's see what happens. We could also get just 1 x-intercept. Now that seems weird because how could this function only cross the x-axis once? So we can get 0, 1, or 2. Well, what would that 1 look like? Well, the 1 could look like this, and it only touches here. Or it could look like our typical parabola, and it crosses at 0, 0. Or it could look like this. And again, this would only have a single x-intercept. All right, so how do we find our x-intercepts? We are going to plug in 0 for y. Well, remember that the f of x means y. This is the same as if I wrote y is equal to x squared minus 4x plus 3. But this time, I don't want to substitute x for 0. That's what we did to find the y-intercepts. This time, I want to substitute y for 0. So I'm going to put 0 right here. Where I see y, I'm going to put 0. And then I'm going to solve this equation. Okay, well, solving this equation, we're going to solve it by factoring. And this is a 3-term polynomial, hippobutts. This is a positive here. So I'm going to have a -3 and -1. Multiplied together is this +3, sum to that -4. Great. Okay, so I get these values. Well, again, I'm looking for the value that would make this 0. So I've got x minus 3 is equal to 0. So x is 3. And I've got x minus 1 is equal to 0. So x is 1. Well, but x is only 3 and x is only 1 when y is 0. So my x-intercepts here are 3, 0. Right? Because this is all equal to 0. Again, that's equal to 0. So when x is 0, y is 3. When y is 0, x is 3. And when y is 0 again, x could also be 1. So here we got 2 intercepts. This means that this graph is going to cross the x-axis twice. So this is this 2 right here. We get 2 x-intercepts. Okay, well, let's plug in 0 for this one and see what we can do here. All right, well, this is a 3-term polynomial with no GCF, but this doesn't have a coefficient of 1, so I can't use hippobutts to factor this. I'm going to have to use synthetic factoring. So I'm going to say that 3 times -10 is a -30. I'm going to look for factors of -30 that sum to a -13. That's going to be -15 and a +2. Going to write those over A, and we get the factors here. Remember that when you're using synthetic factoring, you can reduce these, which again, this will reduce to a -5/1 and a 2/3. We could put these into factors of x minus 5 and 3x plus 2 and solve for 0. But we don't need to, because when we use synthetic factoring, we know that we get these answers right here with opposite signs. So x is going to be equal to a +5 and x is going to be equal to a -2/3. but x is going to equal these values when y is 0. So I will get two ordered pairs here again. The first one will be 5, 0 for this x value, and the second one will be -2/3 and 0 for this x value. Again, when you're using this synthetic factoring, you can just reduce and change the signs. You're going to use opposite signs. So this one also has 2. So we know that this crosses our x-axis twice. What about this one? Well, if I plug in 0 for y, and I were to try to factor this, well, we'd say, hey, this is a sum of squares. And we know that a sum of squares, because it's a sum, because it's adding, this is a perfect square and this is a perfect square. There's no x term, it's missing this bx term, right? This is a sum of squares, and we know that a sum of squares is prime. It can't be factored. Okay, so if we get prime here, then we have no x-intercept. Well, that's true, but why would this happen? Well, if we look at this graph, what it actually looks like, we know that x squared, looks like this, but this is going to shift it up 1. So the x squared plus 1 is just going to look like this. And you can see this green graph here that is this x squared plus 1, it's never going to cross the x-axis, so it makes sense. It has no x-intercept. Okay, I can buy that. Now I'm going to try this one, and I'm going to say that 0 is equal to -5x squared plus a 5x. Well, again, I'm trying to find the value for x, so I'm going to factor this completely. Factor out a -5x, and that'll leave me with x minus 5. And then I'm going to set each one of these factors equal to 0. Again, that's what we would have done up here, but we don't have to because we were using synthetic factoring, so we can just switch these signs. But here, let's just go through this process. So we get that x is 0 and x is 5. Well, again, here, x is only 0 and x is only 5 when, so x is 0 when y is 0, and x is 5 when y is 0. This is the definition. When y is 0, then we have these x-intercepts. This shows you how you could get 2 intercepts and how you could get no intercepts. We didn't do one that has 1 intercept, but it would have 1 intercept. We could do one of those real quick. Let's see if I can just make one up. Let's say that we have the f of x is equal to x squared plus a 10x plus 25. Let's say that it looks like this. Okay, so when I plug in 0 here for x, or for y, for the value of y, sorry, we're plugging in 0 for y to see what x is, and I factor this, hey, this is a perfect square trinomial. Okay, so again, this is a perfect square here, so this is x, 25 factors to 5. 5 times x is 5x, double that is 10x. So this is a perfect square trinomial. I dump this sign right here and I'm good to go. But what does this graph look like? Well, it looks like a parabola, but it has done what? Well, it has shifted horizontally -5 units. So what does this look like on a graph? Well, it looks like this. Let's do this. 1, 2, 3, 4, 5. So it shifted over here and is going like this. All right, well, this only touches right here. But how would we get that this only has 1 x-intercept? Well, we know how to solve this. We didn't actually finish solving this. We factored it, but we didn't set this factor equal to 0. Well, it literally says 0 is equal to x plus 5 squared. So to find the value, I want to square root both sides. Well, the square root of 0 is 0. And the square root of x plus 5 squared is x plus 5. So I'm going to subtract. And I get that x is negative 5 when y is 0. And you can see here that we only have a single value of negative 5. So there's only one intercept here. So that's how you get x-intercepts, either 0 if it doesn't cross the x-axis, 1 if it only touches it, and 2 if it crosses it twice. Okay, so identifying the axis of symmetry. The axis of symmetry is just going to be a vertical line at the x value of the vertex. So again, it's going to be a vertical line at the x value of the vertex. So if we found the vertex, which we know how to do, then our axis of symmetry will be the x value. So let's say that we had, something in this form, and we figured out that the vertex is at negative 2, 10. And let's say that it was in this form, and while it was in this form, we saw that it was a vertex of 4, negative 3. Well, what is the axis of symmetry here? Well, our axis of symmetry, if this is the vertex, the axis of symmetry is x equals negative 2. It'll be a line. So we got 1, 2, and this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our vertex is here. And this parabola, we don't know much about it. We don't know if it opens upward or downward, but we know that it's going to look the same through this line right here. It's going to be either upward or downward, depending on what the original equation was. But regardless, it'll be symmetric about the line x equals negative 2. So the axis of symmetry here would be x equals negative 2. These are connected. Where the vertex is tells me how to identify the axis of symmetry, whether I'm getting it from this format or this format. The axis of symmetry here would be 4. Again, it's just going to be the x value. All right, so how do I know if it opens up or down? We talked about that a whole bunch too. If the x value, so say like I have the f of x is equal to negative x squared plus 2x minus 5. Well, right here, because this is a negative, this is going to open downward. And when it opens downward, we will have a max value. The max value will be at the y value. Okay, so it'll be y equals k. So if it opens up, that's if a is positive. It opens downward if a is negative. And we will have a max. Let me rewrite these. If it opens up, we have a min. Okay, so these match. If it opens upward, we have a min. And if it opens downward, we have a max. Again, the other videos talk more about max and min, but this max and min value will be at the y value of the vertex. So this is also linked to step 1, just finding that vertex. So the y value of the vertex will be the max if it opens downward, and it will be the min if it opens upward. More in the other video. Okay, so now that we know how to do all of those different things, the last thing that we need to know how to do in this section is to take something that's in this format and make it into this format. So let's say that we have the f of x is equal to x squared plus 8x plus 7. Well, using the vertex formula, I could find the vertex. I could do everything I wanted to if it's in this form. But I want to see it, I want to make it be in this form. So what we're going to do is we're going to isolate the x terms. And remember that f of x is just y. So I'm going to replace this with a y, and I'm going to subtract 7 from both sides. So it's going to say y minus 7. So I've isolated on this side the x terms. There's no constant. Okay, again, that's going to look like y is equal to the ax squared plus bx. It's going to be equal to y minus c is equal to the ax squared plus bx. If we're looking at this general form, we just subtracted the c over. That's what this is. Now I'm going to complete the square. And just for a real quick review, to complete the square, we're going to use b over 2 squared, the value of b over 2 squared. All right, so what is that going to be? Well, b right here is 8 over 2 squared. That's going to be 4 squared. So I'm going to add 16 right here. Whatever you do to one side, you have to do to the other. So remember to add the value to both sides. All right, so we add 16 to both sides, and we get y plus 9 is equal to this perfect square trinomial. Well, my next step here is going to be to put this perfect square trinomial, so put the perfect square trinomial in factored form. Okay, remember that if we have plus 2ab plus b squared, this is going to factor to a plus b squared. And if we have ax squared minus 2ab plus b squared, this is going to factor to a minus b squared. So this should be old hat. We should have this memorized and be able to pull this out when we're sleeping at this point. Okay, so I've got then x, so that's the a value, and 4 is the b value, and the sign that goes right here is going to dump in there. Again, so these signs right here match. Okay, so you know what sign goes there. So it's going to be positive, and then what I'm going to do now is write it back, solve it for y. Okay, so we put it in the factored form, and we're going to solve for y, which we also know as the f of x. Okay, so I'm going to subtract 9 now from both sides, so I get that y, or we're going to call this the f of x. The f of x is going to be equal to x plus 4 squared minus 9. Okay, so I've now taken something that's in this format, the standard form right here, and by completing the square, I've been able to write it in this vertex form here. So I can identify my vertex here is going to be -4 and -9. So this is how you find the vertex. Again, the vertex here is going to be h, k. And h is the opposite, so this is a -4. All right, so this will help you identify the vertex after you put it into this form. We've already gone through how to identify the x and y intercepts, whether this is opening downward, upward, so you can apply all of that to this, and we'll go all the way through a couple problems, but I just want to do a couple more to put this in vertex form. So this is a longer video again, but that's okay. F of x is going to be equal to 3x squared. Let's see. Plus a 12x plus 16. All right, so my first step is to isolate the x terms by subtracting 16 from both sides. That means I'm going to replace the f of x with y. And here, remember that I want to complete the square here, but I can't complete the square unless the coefficient of the x term is 1. So when I'm completing the square, I need to factor out only the constant, which could also be a negative, could be just a negative, but we want to factor out the GCF. Not the GCF, but only the constant GCF. So here I'm going to factor out just the 3. I need to leave the x squared and the 4x here because I want to complete the square. I want to make this a perfect square, but I'm going to factor out this 3 and leave this space here. Well, that means then that my b is now this value right here. So to complete the square, I'm going to take b, the b value divided by 2, and square it. Well, 4 divided by 2 is 2, and 2 squared is 4, so I'm going to add 4 here. But I've got to add the value to both sides. This is not just worth 4. I didn't just change this side of the equation by 4. I changed it by 3 times 4, which is 12. So I just added 12 to this side of the equation by sticking this here. So I have to add 12 to that side of the equation. Again, the sum total is not 4. I didn't just do this. I did 3 times 4 because this is part of this parenthesis in here. All right, so that gives me then y minus 4 over here. And I want to write this right here in the factored form using this. So I'm going to have x, I'm going to have 2, I'm going to have a plus because this is plus. All right, so I've now written this in factored form. Now I'm going to solve for y by adding the 4 to both sides, and we will get then that the f of x is equal to 3x plus 2 squared plus 4. And once you get it to this form, they're going to say to you, what is the vertex? The vertex is going to be the h value, which in this case is -2, and the k value, which in this case is 4. So this is my vertex. Again, it's going to be the opposites, because this is a positive, it's going to be a -2. So here is the vertex, and this is putting that parabola from standard form to vertex form. Let's do 2 more here. Just going from standard form to vertex form so you can have these to refer to. Let's do the f of x is equal to -x squared plus a 2x minus 1. First step is I'm going to add the 1 to both sides, so I'm going to have y plus 1 is equal to -x squared plus 2x. Again, I want this coefficient right here to be just 1, but it's negative. So I'm going to factor out the negative. Okay, so I'm going to pull out the negative here, and that's going to change this to x squared minus a 2x. Now I'm leaving space here for whatever is completing the square. So to complete the square, I'm going to take this b value, divide it by 2, and square it. Well, -2 divided by 2 is -1, and -1 squared is a positive 1. So I'm going to add 1 to this side of the equation. But I didn't add 1 to this side of the equation. I added a -1. So that's what I need to do to this side of the equation. I need to add a -1. That makes it so I just have y over here. And I need to now write this in its factored form. So I still have this negative floating around. In the factored form, this is going to be x minus 1 squared. All right, so where's my vertex? My vertex is at the h value, which in this case is 1, and the k value, which in this case, there isn't 1. So this is plus 0, so the k value is 0. All right, so this is the vertex here at 1, 0. We know that this parabola is going to open downward because it has a negative, and that means it's going to have a max as well. So just kind of throwing these 2 tidbits in here for you. On this last one, we're going to do the works on it. Okay, so we're gonna go through and find everything on this last one. So this one was just how to get it into vertex form, but here we're gonna do the whole enchilada here. So we've got negative x squared plus a2x minus 12. I'm going to put it in vertex form. Start by adding 12 to both sides. So I've got y plus 12. That's going to be equal to, I've got to factor out that negative. So I'm going to have x squared minus a 2x. It was like we just did this problem. Negative 2 over 2 squared is going to give me a positive 1 here. But oddly enough, again, this negative means that I actually subtracted 1 from this side, so I have to do the same thing to that side and subtract 1. So I'm going to get that y plus 11 is equal to negative x minus 1 squared. I'm going to subtract this 11 back over to the other side. Okay, so I'm solving for y. So the f of x then is going to be equal to negative x minus 1 squared minus 11. So now we're going to go through all those things that we did before. We're going to find the vertex. The vertex here is going to be 1, negative 11. 1 because this is the value of h. This is subtract, so that is the value of h. Here I've got negative 11, so that is my k value. The other thing we want to know here, we're going to say, what is the x-intercept? Well, how do I find the x-intercept? I plug in 0 for y, right? This happens when y equals 0. So I'm going to plug in 0 for y into my original equation. Okay, plug in 0 for y and factor out the negative. And I can just like divide that negative away, so boom, it's gone. Okay, we'll divide both sides by negative 1. And now I'm going to try to factor this. So if I look at the factors, I'm going to get 1 and 12, 2 and 6, and 3 and 4. And if you look at these factors, you can see that they're never going to sum to this negative 2 right here. So what does this tell us? This tells us that we have no x-intercepts. Okay, so we have none. Well, that means it either opens above and opens up, or it opens below and opens down. Well, we know it opens downward. So, but it never crosses the x-axis. That's what this means. So we have no x-intercepts. There are none. No x-intercepts. All right. But what about the y-intercept? Well, how do I find the y-intercept? The y-intercept is when x is 0. So if I do the f of 0 into here, say substitute 0 for every x. For everywhere I see x. This is nothing, this is nothing, and when x is 0, y is negative 12. Okay, it's this value right here. So this is my y-intercept. Oops, this equals my y-intercept. Okay, at 0, 12. All right, so I found my x-intercepts, that we don't have any. Found my y-intercepts. Y-intercept, excuse me, 1. We know that the vertex is right here. This opens downward. So could we graph this and identify the max, min, and the axis of symmetry? Well, let's see. We've got a y-intercept of 0, negative 12. And let's erase all of this and just for kicks and giggles put this on the graph. So I'm at 1, negative 11. So this is going to be very far down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm at 1, negative 11. Again, this parabola is going to open downward, and we know that we have the y-intercept of 0, negative 12. So it looks like, and it's got to be symmetrical, so it's going to look like this. Again, this is the vertex of 1, negative 11. And this point right here is the y-intercept that we got. And we know that this opens downward. So this is sufficient graphing when you've labeled the vertex and any intercepts. And then if we said, hey, does this graph have a max or a min? Well, it's going to have a max. because it opens downward, it will never go above this point right here. So the max is going to be y is equal to negative 11. Does this have an axis of symmetry? Well, every one of these do, and that axis of symmetry is going to be at this line, x is equal to 1. Again, the axis of symmetry is at the x value of the vertex, and the max or min is at the y value of the vertex. So this is pretty thorough covering, long video, but I hope this was helpful with all the different things that you will need to know.